Today we're going to talk about impact force, some of the physics behind it, and a common misconception that many martial artists have. There's one physics equation that martial artists mess up more than any other. In fact, I've seen this equation misrepresented in books. I've seen it misinterpreted online. What is this equation I'm talking about? Well, it's none other than F equals ma, or force equals mass times acceleration. And it makes sense that if you are given this equation, you're going to look at it and say, well, if I can increase the effective mass that I'm striking with and I can increase the acceleration of that mass, I'm going to increase the overall force that I hit my opponent with. And that force is determined by mass times acceleration. But that's not what this equation is telling us. It has nothing to do with the force that a mass can deliver, and it has everything to do with the net external force acting on a mass, causing it to accelerate. If the net force acting on a mass is equal to that mass times its acceleration, what exactly does that mean? Well, now that we have our extension cord around Bob, we can look at exactly what's going on. And it's really quite simple. See, if I pull on Bob and Bob's not accelerating, we know that there has to be some other force pulling back. And when I say when I pull on Bob, really I'm pulling on the extension cord, which is then pulling on Bob. But either way, there has to be some force pulling back. Otherwise, he would accelerate. And that's what we're talking about. We have to add the forces together. Now, some of those forces can be positive and some of them negative. We could say that the direction towards you is positive because I'm pulling in that direction and Bob's facing in that direction. And then the opposing direction is negative. So there has to be some negative force that's working against me. That's what F equals ma is telling us. Likewise, if I pull hard enough that he starts moving, now I know that when you add those forces up, they don't cancel each other out. There has to be some force in the positive direction. That's the force that's causing him to accelerate. And so you see, when we talk about F equals ma, we're looking at the force that's acting on the mass, the force that's causing that mass to accelerate, not the force that that mass can deliver to another mass. I have 3 weights that I'm going to drop. Now, what's important isn't so much that you see the weight as it's being dropped, but rather I want you to listen to the weight as it's being dropped. Now, I'm going to drop the 2 5-pound weights first. I'm going to drop one and then the other, and I'm going to drop the first one at about waist height, and then the second one I'll drop at around shoulder height, or maybe even a little bit higher. So here we go. Here's the first weight. Again, I really want you to listen to what's happening, and I might drop it even a little bit below waist height, just so that we have a reasonable difference to illustrate what's happening. Now, here is our second weight. Listen close. This is a little higher than shoulder height. And if you have to, you can play it back, but you should be able to hear the second weight had a slightly louder impact than the first weight. Now, I'm going to take our 10-pound weight and I'm going to drop it at about the same height as our previous weight. So I want you to compare these two together now. And in that instance, you should have heard an even louder impact, the loudest impact yet. So what's happening? Well, first we have to understand that all of these weights are falling with the same acceleration. It's something called the gravitational acceleration constant. It tells us that I could take any of these weights and pair them up, drop them side by side, a 5-pound weight, a 10-pound weight, a 5-pound weight, or a 20-pound weight. And if I drop them from the same height and I release them at the same time, they'll hit the ground at the same time, because acceleration due to gravity is a constant. So what does that mean? Well, if you compare the two 5-pound weights that we dropped, the only thing that changed was the height. The mass was the same, the acceleration was the same, but the impact was louder because the force of impact had to be larger. Why did the force of impact have to be larger? It wasn't the acceleration that changed, it was the velocity. By changing the height, I gave that second weight more time to accelerate, which meant when it hit the ground with a larger speed. Now, if you compare the last two, so the second 5-pound weight with the 10-pound weight, I dropped both of those from roughly the same height. The acceleration was the same, but now the mass changed. So the speed would be the same on impact, but again, the mass changed. So mass and acceleration aren't going to determine your impact force. We saw that with the first two weights. They both had the same mass, the same acceleration, but a different impact force. We could tell it was a different force by the sound of the impact. What does play a role in determining your impact force? Something called your momentum, which is not a product of the mass and the acceleration, but rather a product of the mass and the velocity. So the lesson, go to work on maximizing your effective mass as well as maximizing the speed of that mass. If you go to work on developing those two things, you're going to be on your way to maximizing your impact force.